So this one here is either going to be part 4, right, because it plateaus out, or part 1. Should they all approach a particular value, but this one doesn't have any variance in the slope. Okay, so it's either going to be this one or this one. So what is the difference? This one here, so when it's 1, let's say 1, 1, and negative 1 and 1, this one, if this has a slope of, let's say, half, this has a slope of negative half, right? And this one, right, whether it's when you plug in 1, when you plug in negative 1, the slope will be opposite sign. Do you see that? It's because of this x. So this one belongs to this one. Okay? And note that this one looks very similar to this except without the x. So it has the same plateauing effect, but because it doesn't have the x, the slope on the opposite end, so 1, 1, 1 or negative 1, negative 1, negative 1 will have the same slope. So this one here is this one. Here, right, the derivative is equal to, actually, we can even say sine of 2xy, double of the xy. A constant slope. It has a constant slope of 0. So let's see when that happens. Sine of 2xy is equal to 0 when 2xy is equal to, right, 0, pi, 2 pi, so 0, so it's going to be pi times k, where k belongs to set up any integers. Okay, so that means xy is equal to pi over 2 times k. So what does this mean? Okay, so let's just play with pi over 2. That means y is equal to pi over 2, right? Pi over 2 over x. This 3.14 over 2. But this is a reciprocal function, right? So it's going to look essentially like this. So any point on here, if you plug it in here, it's going to equal to 0. Any pair of values in here. Pi over 2, it can be pi, it can be 2 pi, it can be negative pi over 2. So, you know, even any graphs on here, any values in here, right? So it's a lot of different values. Okay, infinite set of values will make the graph have a slope of 0. So we're definitely talking about this.